All right. All right, we are back. This is Computer Science S76. So there weren't too many questions from you, so that means it's my turn to start asking questions. Last week we started talking about MVC, which, how about we'll start with the softball, stands for what? Model View Controller. Okay, so what is the controller in that acronym? Okay. Brains of the application. So it's the code that you write, the so-called business logic that governs the control of your application. It's the entry point to really the logic that you write. All right, how about the view? Yeah, so interactions with the user. So view typically deals with presentation, both the aesthetics thereof, so how you're displaying information to the user, and then it typically has some UI mechanisms like buttons and text fields and whatnot that somehow send messages back to which of the letters? The controller. So you have this bidirectional arrow essentially between your C and your V, so the two are talking, but you do not have an arrow between, say, V and M directly. Rather, the model is where you typically represent your data, and we'll do a simple example tonight of what you might want to model with its own class that we write ourselves. But typically, all of those communications should be marshaled through the so-called controller. So that's where really the intellectual property of your app tends to be. And the aesthetics are in the view, and then the model is where we'll do our data typing and our data representation and encapsulation. We'll do a bit of that in just a bit. All right, so that was MVC. And in what form does this take in the world of iOS? Well, in iOS, we have a few classes within UIKit. So this is the API that provides access to UI-related things in iOS. And UI application was a class that we barely spent any time with because we just make a reference to it in main, essentially, where we have a new UI application. And that's the class that embodies your actual application. But beyond that, we don't really need to care too much about it. But UI application delegate is a class that we spent a little more time talking about. And what is that class's role when you create an iOS app? Use it in a sentence that makes it sound like technically you're comfy with what its role is. So it's where you put your code, or at least the first entry point. You wouldn't put your code in main.m, but rather you might first put it in the UI application delegate. And conceptually, it's to this class, or an object thereof, that control of your application is delegated or passed. So he's now the guy in charge. But as soon as we started doing more interesting applications than just rectangles on the screen and started getting interactions from users, we further delegated control from the UI application delegate to an object of what type? UI view controller. And we don't have to per se. Games don't necessarily use that same class, and custom applications don't necessarily use that class. But the UI view controller is nice because it comes with a whole bunch of built-in functionality for handling various common paradigms like buttons and sliding and tabular views and so forth. So it's a common starting point, certainly for the types of menued applications we've looked at thus far. And a UI view controller, in turn, makes use of a bunches of UI view objects, but typically not just generic UI view objects. What are some subclasses that we've used and talked about? Two of which I've enumerated tonight, albeit off camera. Starts with UI, ends with button. Okay, so UI buttons. So this was just a subclass. And thus far, we've essentially used these things by dragging and dropping. But we did have a quick glimpse last time at nonib.xcode project, which was a re-implementation of that super simple app that gave me a text field for my name, gave me a button to click on to actually then trigger a UI alert view saying, hello, David, or hello, such and such. And we dragged and dropped that UI button, but UI button is just a specific incarnation of UI view. And if you think back to Xcode and think back to interface builder, that drag and drop interface, what we're essentially doing by dragging and dropping is dropping these little objects on top of a canvas. And they can overlay, overlay, overlay. And we'll do a little more of that in a different sense tonight by actually responding to arbitrary key presses or pinches for zooms and the like. So we can actually listen to the entire UI view, as we will see. UI window, finally, was a special case of a UI view. It has some additional stuff baked into it that essentially describes the full rectangular area of the iOS device in question. But today, we'll spend a bit more time in UI view controller and UI view, but we'll see those other classes again along the way. So Let's see. So last time, we looked at a whole bunch of these templates. None of these templates are strictly necessary. You could just start with nothing in your project and start writing files by hand. The problem is you just end up reinventing the wheel. There's a lot of configuration details that we saw in the form of property lists, those key value pairs, that would just be a pain to do manually. So Xcode helps jumpstart things either with an empty application, which has the bare minimum of configuration. And then we looked at single view last time. And in lab, you looked at utility view, and you're knee-deep in a utility view application for Evil Hangman. So if we proceed a little further today, let's take a look at these two last ones. Not because they in and of themselves are applications you'll need to use for the project, but rather because they're illustrative of somewhat more complex applications that you might implement that nonetheless assume familiarity with the overall structure we had earlier. So let's do this. First, let's start somewhere simple. I'm going to go into Xcode, and I'm going to first start not with an empty application, which was super uninteresting by the end of last week, but single view application, and then we'll quickly build on from there. I'm going to go ahead and call this single view. I'm going to just store it on my desktop. I'm going to uncheck storyboards here, click next, then I'm going to go ahead and click OK. And now we have the following boilerplate files. So suppose, by contrast, I didn't just create this right in front of you, but you were handed this project from someone else, and you want to wrap your mind as to what's going on inside of it. Where's the best place to start to understand what you've been handed?
In the .h file, viewcontroller.h.
Okay, viewcontroller.h. I would propose that's maybe a little too deep at first glance. Why don't we start where the beginning of the story begins? Yeah, app delegate, and really, if we want to be super anal about this, technically it's main.m that kickstarts the whole process, and a quick glance should at least reassure that there's nothing special, nothing different there, but indeed it's in this file that we see mention not only of UI application, but also app delegate, to whom we're going to delegate control. So we've confirmed that there's nothing distinct in there. So now I would propose among the app delegate files, starting with the .h is probably the better place, because it gives you, in theory, an overview of what's about to go on, and it also gives you a sense of what needs to be implemented in the .m file. So what's going on here? Well, quick recap. The import line does what for us?
It imports the user interface kit.
Okay, good. It imports the user interface kit. And what does that mean? So in that .h file, there's a whole bunch of class declarations, perhaps, maybe a bunch of constants that are defined, a whole bunch of things that we want to take for granted exist. And this is our way of teaching Xcode that we want to use the code that someone else wrote. All right, on the next line, we have @class viewcontroller. Actually, that's a little strange. There's a semicolon, yet no implementation of the class. What is it with this line here, @class viewcontroller, which we've not really spent time on? Yeah?
So the @class actually tells it that it is a class, but it doesn't actually import it.
Exactly.
Unless you were going to use one of its methods, that should suffice to tell it that it exists.
Exactly. So we didn't spend time on this last time, but this is what's called a forward declaration. It's a little hint to the compiler saying there is going to be a class called viewcontroller. I'm not going to tell you anything more about it, but if you see mentions of viewcontroller elsewhere in this file, don't complain. Don't give me any red warning saying that's not allowed. This is just teaching the compiler what's actually going to come. And indeed, where are we using that? Well, a few lines later, we're declaring a property whose purpose in life is to store a pointer to a view controller object. So this is, long story short, a way of avoiding potential circular references whereby one file might import another, A common paradigm is if you only need to make mention of the class in this way in your .h file, just to use a forward declaration and not to import the whole viewcontroller.h file, for instance. Okay, what's this third, more interesting line saying? @interface, app delegate, UI responder, angled brackets, UI application delegate. Let's start easily. This just declares what? What's this mention in black of app delegate? Name of the class, all right? The UI responder means it's the UI responder is the parent of the class, so app delegate is going to descend from UI responder, and someone else, the UI application delegate in angled brackets? It's a protocol. So we're saying that we are going to implement the UI application delegate protocol, and this makes sense because the class, after all, is called app delegate. All right, what are the two properties? Well, we saw one view controller. We have another pointer to the UI window. That'll give us access to the full rectangular portion of the screen, and that's it. All right, so now let's dive into the M file. All of that is boilerplate. None of that is different from what we saw last week. This file is always a little overwhelming at first glance when you have all of these comments, but that just means they're not really doing anything. So let's ignore anything that's not actually doing anything functional and focus only on this first method up top named, what's the name of this method that remains? Not app delegate, so that's the class name. The name of the method is? Yeah, application did finish launching with options. So longly named method there, but what's this doing? So first it's allocating a window. It's initializing it with a frame. That's just referring to the rectangle as we keep describing it. View controller gets, so here is where we are effectively configuring our app delegate with another guy to whom we're going to delegate control, the view controller. Self.viewController is a property that's built into the app delegate class. So if you actually look up the documentation for a UI application delegate, you'll see that it comes with that property. So we are setting it in that way. Finally, we're setting this is our property that we declared in the .h file, but it comes with a root view controller property in the window. That's in the UI window documentation. And then that second to last line, make key invisible, just gives control to the UI controller to the foreground. What else does this application do? Anything? So that's it. All we have is a nib where we could start to put our user interface, but beyond that, this application does terribly, terribly little. So let's try to see first. Any questions? So let's take a more complex tour and see if we can't now understand a new application entirely, but this time while thinking about it in the context of applications we've seen thus far. So among tonight's source code is a folder called master detail. This is essentially a simplified version of the standard template that comes with Xcode. So all I did was tidy things up and remove things that didn't need to be there. As usual, let's go into our main.m file. Let me close some superfluous windows over there. Nothing new happening here, so that's the same file we saw earlier. What file should we probably dive into next, following the same rule of thumb? Okay, so app delegate, start with the .h. That looks perfectly the same, so nothing new there. AppDelegate.m, so here we have what seems to be the same code as before, except for any differences? So we're instantiating a master view controller. So that's interesting. It's not just a view controller, it's a master view controller, and we're making it the root view controller, so to speak. So most of this code is the same, but I'm instantiating a different class name, but that's because someone at Apple decided for this template that we're not going to have one view controller implemented for you in .h and .m. We're going to have what appears to be two, master view controller and detail view controller. So at this point, I'm a little puzzled as to what this thing's going to do. So let me go ahead and just run the application and see if we can't then work backwards as to how the behavior we're about to see is functioning. So let me go ahead and foreground the simulator, and in just a moment we'll see it pop to the foreground. Lately the simulator has been loading a little slowly, but there we have it. And now we have, interesting, an application that has nothing going on here. You can just about see the horizontal line. So this is some kind of tabular view going on. And this application, the starting point, is designed just to do something stupid, just to insert a new row every time you click the plus, and it's choosing the timestamp in UTC, so universal time, and adding a row accordingly. So if I do that ad nauseum, we'll just get lots and lots of rows. But you might recall this paradigm in iOS. If I click Edit, I get this familiar UI. I can go ahead and delete, say, that one by clicking that circle, then clicking the delete button. Then I can say Done. And so there we have that functionality. And if I click a row itself, detail view content goes here. So what's just happened, apparently, is that we've made some kind of transition from the master view controller to what they call the detail view controller. So this is illustrative now of how you can hand off control between two view controllers. Recall that you've essentially been doing this in the utility application, or you will soon be doing this in the utility application for Evil Hangman, but you were choosing a different type of transition. Rather than side to side, you were doing front to back flipping. So this one still is a little different in its implementation. Let's next go into, from appdelegate.m, let's start with masterviewcontroller.h. Is there anything of interest in here? So master view controller has a property that's going to store the address of what kind of object? Looks like a detail view controller. So if you think about this high level, the root view controller is the master view controller. He apparently is somehow going to have attached to him the address of a detail view controller. So it seems to be the case indeed that the master view controller is in charge. Now we haven't done any of that wiring yet, so let's go into the .m file for master view controller, get the lay of the land. Damn, this looks a little overwhelming, but we'll get there. So now let me scroll back up to the top and see what's interesting here. So let's focus first on one of these at a time. So here's a method called initWithNibName. This has typically been called automatically for us because we've had a bunch of starting points in our applications thus far in class where we had those .xib files. Somehow they were wired up to my code and loaded automatically, and we just initialized them based on the XML file that is the .xib file somewhere on my hard drive. But now we're explicitly implementing an initWithNibName bundle method, and if I hover over this thing and check the question mark, notice that there's a whole bunch of documentation in here, and this method appears to come from an ancestor class known as UI view controller. So if we really look underneath the hood, master view controller descends from a new class that gives us the tabular view, UI table view controller, which in turn descends from the thing we've seen in applications thus far, UI view controller. So long story short, if I actually start to read this documentation, this will explain how the initWithNibName bundle method works, and it is the guy that's responsible for loading from the hard drive that .xib file and somehow making all of the connections we discussed last weekend in lab. So it's doing one additional thing, though. It's calling first the superclass's implementation of that same method, initWithNibName bundle. So that's been called automatically for us because we have not explicitly implemented this method thus far. But it's also doing what in high-level terms, apparently? What does it appear to be doing? You seem to have a guess in mind. Oh, yes, you. Initializes the first line does. Yes, sorry. Let me change my highlighting. So it's not commented, but what do these three lines seem to be doing? Yeah, it's setting the title of self. So self.title, what is self? What type of object is self at this point in time? So it's a master view controller, which in turn is a UI table view controller, which in turn is a UI view controller. So if we really started poking around the docs, we would probably see that UI view controllers have a property called title. And indeed, that's where this is coming from, or UI table view controllers. And if we go back to the application that was running, notice when we're here, the title master, that's where that came from. So we could have typed this in manually into the nib, but because we created the view controller in code, we don't actually have to do that there. All right, so this, as an aside, is a common paradigm. Anytime you modify self, it's common to check if self is non-null, so that is if everything went okay and the previous line did not return nil, meaning there's some memory error or the like, you check first that self exists okay before touching one of its properties, as we did here with self.title. All right, so next, I think we saw this last time. View did load. We saw this in our no-nib example, I believe. View did load, if we read the documentation, is just the method that's called when the view did load, so aptly named. And what does this guy seem to be doing? It's wrapping a bit, but it's about 4 lines of code total. Yeah, it seems to be adding the edit button. So first we call the parent version of the method, and if we read the documentation, we will be reminded typically, be sure to call the parent before you do your own thing. Self.navigation.left button bar item. I don't really know where this comes from, but I can probably guess that because we are implementing a subclass of a UI table view controller, presumably a UI table view has a property called navigation item. And that navigation item refers to the little blue or gray bar at the top of this kind of application. And .left button item refers to .left bar button item refers to the thing at top left. And we seem to be storing what there? Self.edit button item, whatever that happens to be. And then UI button item, add button. So if we read this, we're apparently instantiating a UI bar button item, allocating it, initializing it with this thing, UI bar button system add. So there's a lot of code there. That's not all that interesting to dwell on now, but if you think back to what's going on, this is really just the code version of going to something like my nib, opening up the toolbar over here, scrolling down to the objects down here, And if we scroll, we'll eventually find navigation bar and navigation item. So what I'm doing in code is the equivalent of dragging and dropping this into the user interface, much like we were doing last week. So that's all. The magic that we've been taking for granted of dragging and dropping is now being implemented more lower level in code. All right, so let's not worry too much about the user interface, because that's not all that interesting at the end of the day. Let me just point out a few of the additional methods we've implemented. These are methods that we've implemented because we need to implement table-related functionality. One of these is super simple. The method called number of sections in table view, if you read the documentation, its purpose in life is to return a number, namely how many rows should there be in the table, so that the operating system knows when to stop rendering rows. So in this case, we've just returned, sorry, not rows, sections. So sections are groupings of rows together, and if you have an iPhone and you go to your settings menu, you'll see that there are rows in your settings menu, but they're typically clustered with some kind of bold header. That's referring to a section. We had no such aesthetics here, so we just have one massive section. So they have hard-coded the value of 1 in this template. So next, table view, number of rows in section. So this is the method that tells the program how many rows should actually be in that table, how many dates have been added to the table. But what is underscore objects dot count? Where did that come from? Yeah, it probably holds the information for the rows because, again, recall the difference between C and V, controller and view. The view may very well render what looks like a table, but if there's any data that you're rendering, it's the controller's job in life to actually keep track of that and just pass it to the view. So we shouldn't be storing those dates in the view per se. We should be storing all of those dates after every click of the plus button somewhere inside of my controller and then just handing it to the view. So underscore objects, if we glance back at the top of the file, was actually declared up here. And I've declared an NS mutable array. What's the difference between mutable array and NS array? You can modify it. So it's mutable in that you can change it. You can add, remove to and from it. So I've done @interface master view controller open paren close paren. So again, we've already did that, I thought. In the .h file, we had @interface master view controller open curly brace. Why have we repeated ourselves and added these parentheses? For it to be private, or to the illusion of privacy. So we've used an unnamed category here. So recall that categories are just ways of grouping related functions, but the world as a convention has adopted it as a means of approximating the idea of private methods and private data members, private only in the sense that they are not being declared to the world in the .h file, because .h files can be imported by other people, which means other people would see our implementation details, but they're nonetheless adding it to the class master view controller because it's inside of this declaration. So we apparently have an NS mutable array underscore objects, but where is that guy first used? Well, let me scroll down and scroll down and scroll down, and it looks like, let's see, where's our underscore objects? Ah, there we go. Exactly. So here we have a method, insert new object, colon. So what do you think is inducing this method to be called, based on what we've seen thus far? So hitting that plus button. And how was that done? Was it done in Interface Builder, or? So insert new object. So again, let's just do a little highlight and copy. Let's see where, oh, interesting. So view did load. We didn't finish that story. We, and Apple, did not use Interface Builder, it seems, to wire things up. They've done it all in low-level code. So when view did load, we started telling that story in terms of the left button bar item. If we go a little deeper, notice what's happening here. When we declare this UI bar button item and allocate it and initialize it, we are choosing, this is a constant. This very long word, UI bar button system item add, is just the atrociously named constant for the plus icon. That's all that's doing. It's aesthetic. But we're saying target :self action @selector insert new object. So first of all, what is action :@selector insert new object doing functionally? Exactly. When some action happens, which in this case is going to be the touching of the button. That's the default behavior for one of these buttons when it's clicked by a user's finger. What message do you want to send to an object? You want to send this message, insert new object, or put another way, what method do you want to call, and to which object will that message be passed? On which object will that method be called? The target. So target colon self means this class, this object, and that is why, slightly more lower in the screen, we have an implementation of the method that we want to call. So as an aside, the reason that we have this funky syntax, at selector, open paren, close paren, is so that it's clear what the name of the message is that you want to send, because we've seen methods that have colons in them, and it would just get very complicated, if not impossible to parse the string if you had action colon insert new object colon which colon belongs to what. So that's the idea of at selector. It's just a syntactic thing. So that means when you click that plus button, this guy is actually called. So in answer to the question, where is the object's NS mutable array coming from, we instantiate it lazily. The first time we need it, we check, does it exist? If it doesn't exist, that is, if underscore objects equals nil, we're going to go ahead and instantiate an NS mutable array, and then we are going to start populating it. And at this point, if you start to read through the code, you'll see a couple new features. There's this notion of index path, which is something specific to these UI table views. A path is just a tuple of numbers, two numbers together, a section and a row. So an index path is just an object that contains those two values, and if you keep reading further in the code, you'll see that this is the function that actually does the generation of and insertion of a date into that actual table view. Yeah?
A question about, say we would have a property for the object's variable.
Okay.
Would it be faster to use the object with the underscore?
Good question. So suppose we had declared objects as a property. There would be a couple of implications. One, we could do self.objects and mutate it that way. On the other hand, so could anyone else who happens to be importing, for instance, my .h file. If we declared the property there, that we don't have to declare it there, you would get some marginally additional functionality, because by default, the setter and or the getter will often have additional code in them. For instance, if you've declared it to be atomic, it will have some additional code. With the setter will by default make sure that you never set an object equal to itself, which can do some bad things circularly. So you would get some protections, but you pay a price. What's the downside, would you conjecture, of using a property to implement this container as opposed to just declaring a raw pointer like this? It takes longer, and we're talking, negligible amount of time for something like this, where clearly I, the human, am the bottleneck for any slowness in this application, how quickly I can press. But in theory, that's why they've done it in this way. We're the only ones using the property, not the rest of the world. I know how to use it. I just don't need the marginal overhead of a setter and/or getter. But a good question. Okay, so let's not spend too much time on the particulars of this specific application, but let's just scroll through, lastly, the other methods that might be here. So there's this one, table view, cell for row at index path, because this one method actually reveals an interesting design pattern that's not uncommon, especially for performance reasons. So table view, cell for row at index path, and then it's given an index path. The purpose and life of this method, if we read the documentation for the UI table view parent class, is that it is supposed to return a cell, a UI table view cell, so an object that represents a cell in a table configured exactly as we want it. And by configured, I mean what text do you want for the cell, what buttons do you want on the cell, what behavior do you want for that cell. So in short, this method is called when rendering this row, then this row, then this row, then this row, then this row. It is my job to tell iOS how I want each row to look and behave. So what's interesting, though, about this implementation is the following. One, we have this static pointer declared here, cell identifier, that points to a string that's statically declared as quote-unquote cell. This is completely arbitrary. It could be quote-unquote foo or bar or any word there, but it's going to be used in the following way. Down here, I declare UI table view cell, table view DQ reusable cell with identifier quote-unquote cell, quote-unquote foo, whatever word you've chosen. So what is that doing? Well, I'm checking if cell equals nil, that means that there apparently was no reusable cell in my queue. So nothing came back. And so what do I proceed to do? Well, it looks like a common paradigm here. UI table view cell, allocate it. then initialize it with some long, crazy named constant, and also give it a reuse identifier of quote-unquote cell or quote-unquote foo, whatever word you've chosen. Then lastly, change the accessory type to be UI table view cell accessory disclosure indicator. What is that? It's like the little eye icon or similar on the screen. All right, so, or rather the little arrow that points to the right that we saw on the table view when we were in the app. Then we proceed to do what? We grab the object at that particular row. We then update the text label on that cell to be whatever the description is of that object. So in short, the object that we put in the object we put in objects was essentially a date, and then we're just adding that to the descriptive text on the cell itself, and then we return the cell. So most of that was just configuration details. Maybe new in terms of the code we're seeing, but not all that interesting, except for this if condition here. What do you think the purpose is of the relative complexity of these several lines? Why this queue? Why this reusable thing? What's going on?
Make sure you don't overwrite the cell, or just make sure it's unique.
Okay, so make sure you don't overwrite a cell, make sure it's unique. True, but we could do that by just allocating a new cell for every one of the dates in this table, or every one of the words that I want to put in this table. Why else might I be introducing this complexity of some kind of queue of reusable cells?
You want to change the value inside? Or?
Want to change the value inside. So that's true, but why? What's the motivation? Let me press further. Suppose that you can view 10 cells on the screen at once based on the height of your iPhone and the height of your font, and you have allocated, let me say, if you only can display 10 rows at a time, but you've got 100 dates because you've hit that button 100 times, technically, only 10 of those cells need to be in RAM at any given time, because the other 90 are down here. The user's not going to be able to see them, so why bother keeping them in memory? So if I give you that insight, why are we apparently using this trick? What's the motivation? Yeah?
To make it faster than everything.
Exactly. It all boils down to memory usage and memory management. So to your comment earlier about really the spirit of keeping memory usage low, you could absolutely just allocate 100 cells for 100 items. And frankly, the user's probably not going to notice any latency when scrolling through them because 100 is not that big. But suppose for Evil Hangman, you decided to make an application that displays all 100,000 plus words at once, and you scroll through that, then you probably will, depending on the hardware, start to notice some latency because there's so much RAM being taken up by all of those rows, and it's completely unnecessary. Of the 100,000, you can only see maybe 10 of them at once, so you only need to have 10 actually resident in memory at a time. So this queue is meant to be a performance optimization. So if you've ever used an iOS application that starts to feel very laggy for some reason, it's probably because they were trying to do too much, and potentially some of that work was unnecessary, as might be the case here. So this is illustrative of that kind of design paradigm, especially as your data sets get larger and larger. Okay, let's not dwell too much on the other methods, but happy to take questions if they arise or are on your minds now. All right, so that just leaves us with one last class, the detail view controller. So this guy, if I go to the .h file, looks pretty uninteresting except for the fact that he's got a UI label and he's got a detail item. I also see mention of IB outlet. What is that again? What's an IB outlet?
It's a reference to a thing that's declared in the nib.
Okay, good. So it's a reference to something that's declared in the nib. So it's a means of my code talking to my drag and drop interface. And in this case, the thing in question is a UI label. So how can I pull up Interface Builder and see that interface? What file do I want to click next to follow this trail of breadcrumbs? Yeah, so detailviewcontroller.nib. And if I look there, looks like indeed someone has just dragged and dropped a UI label. I know that because I can see its description down over here. And when in doubt too, if I go to the right-hand panel and open that up and notice that I'm on the identity inspector, Xcode has a habit of dumbing things down by saying label -detail view controller ... when really that's not all that interesting programmatically. You want to know what type of object is that really. So in the identity inspector, which you can see at top right, you can see that, oh, the thing I've just clicked is actually an instance of UI label. That is what I have dragged and dropped. And again, that's the connection between code and the drag and drop interface here. So let's answer just one last question before we put this template aside. How do we somehow pass control off from the master view controller to the detail view controller? How do we make that transition? We haven't looked at the code yet per se, but where would you look if you wanted to answer that question? How does clicking on a cell lead to a state transition? What file should we look at? Okay, so we want to look at the method that's called when it's actually clicked, and how can I chase down that answer?
We passed in a selector into the constructor of one of the rows.
Okay,
Previous file in the master view controller.m.
okay.
We did a control F for selector.
Selector, okay, so there's a selector for insert new object. We saw that before. Only one match.
There should probably be a protocol somewhere that defines the interface between master and
Okay, so let's see. If I scroll down here, cell for row, can edit row at index path, table view commit editing style. That doesn't sound right. Oh, this one, interesting. And that's exactly right. What Peter proposed is that presumably there's some method that's defined, maybe in that protocol we saw at the very beginning of the story, that is what's called when a user clicks on the row. And indeed, that's the case. This is a common paradigm, clicking on the row in a table. So Apple went ahead and implemented that base functionality for us. So if we want to listen for that key press on one of those rows, we apparently just have to implement a method called table view did select row at index path. So what's going on in there? Well, notice first it takes two arguments. The first is a table view. So that's what table view did the user click on. Maybe there's multiple ones on the screen. And what, again, to be clear, is an index path? Section and a row number. So it's going to be like 0, something for the 0th section, 0 index, and the actual row number. All right, so what are we doing here? We again seem to be doing what's generally called lazy loading. If the detail view controller does not yet exist, if it's nil, what do we actually do? We allocate it by calling detail view controller alloc. We initialize it with nib name, detail view controller. Notice when you call this method, you don't say .xib. Bundle is just referring to what folder is it in. We just say nil because it's in the default. Everything is organized at this top level. And so once these lines of code have executed, we now have a pointer to an object of type detail view controller. So we've got the thing in memory now. We just have to transition from the master to the detail. So what am I going to do next? NSDate object. So just to be clear, what is this next line of code doing? On the right-hand side, we have what type of object? What is underscore objects? An NS mutable array. So if we index into it at a current row, that's going to return an object of what type, apparently? An NSDate. And on the left-hand side, we are allocating what? Let's a little pop quiz here. A pointer, good, to an object of type NSDate. So we're not allocating an NSDate. We're allocating a pointer to an NSDate. So it's just 64 bits, most likely, not the full-fledged object. Next, we do self.detailViewController. Detail view controller. What is self.detailViewController? Where did we see that before? So it's a property that we declared earlier. And .DetailItem, well, what's DetailItem? It's going to be set to the object. Where did I see DetailItem? If I go to detailViewController.h, DetailItem was apparently a property that I stored here. It's a type ID. What does ID mean? Any object. It's a pointer that could be nil, but it's a pointer to any object. So this is just a generic way. We could have been more explicit and stored NSDates. Whoever wrote this template decided to just genericize it a bit. So we're storing something of type ID there. So lastly, in this line, we call push view controller animated yes. So the fact that it slides from left to right, as we can see, is the result of the following. Notice the sexy left to right behavior like that. But if I instead change the Boolean yes to Boolean no, stop the current running instance and rerun, and now go ahead and +++, click here, much less elegant. Right? That's what makes Apple devices Apple, the sexy little slides back and forth. All right. Whew. Questions? Okay, so you may never again use a master detail view controller template, and that's fine. The goal of this was not to walk through just templates that Apple hands to us, but rather a number of the design paradigms that they're leveraging as a result of this so that you can either start with something like this or something simpler, like the simple single view application, and begin to wire things together in the same way. And what this is particularly illustrative of is wiring stuff together, not using interface builder and dragging and dropping blue lines, but writing much more code and doing it manually and precisely. IB outlet in this guy over here? Good question. So detailed description item. For some reason, the developer who wrote this template seems to have gotten bored with actually doing the wiring, and rather the coding, and decided to wire it up. So we can go to the nib file for detail view controller, and if I control click on this thing, we will see that detailed description label is wired to file's owner, and who is the owner of this file apparently? The controller, the detail view controller, because recall, that's the guy that initialized the nib with nib name. So he is the file's owner because he's the guy that called this nib file to life. So that was the one instance of dragging and dropping. Everything else in the master was done in code.
Okay, so that's why it's weak.
Yes. Oh, I'm sorry. I missed that part of the question. Yes, so if we go into detail view controller, we have seen a slightly different feature here. These attributes associated with properties. The reason that this here is weak is that we do not want the, what's the best way to say this? This property in the detail view controller is pointing to an object that doesn't need to be kept around, particularly if the detail view controller, once it goes out of scope, as by hitting the back button, disappears from memory. We don't want to have a strong reference to the detail description label, lest that blue line keep the detail view controller in memory unnecessarily long. So this really boils down, the motivation for this is because the detail view controller is coming and going, we want iOS to be able to reclaim that memory, and so we don't hang on to, in a strong way, these blue lines. And that's the first instance I think we've actually seen of that use of weak for that reason. Good question. All right, why don't we go ahead and take our 5-minute break here. We'll come back and start building something from scratch. And we're back. So recall that there's been a checkbox that we haven't checked thus far because we've been using nibs instead. And nibs are a deliberate design decision because they've given us much more low-level control over our user interface. But popular these days is another feature that we keep unchecking known as storyboards. Anyone familiar with these yet? Use storyboards. If we check that, what we get out of the box? So this is Apple's way of trying to simplify the user interface process further, at least for applications that follow some common iOS paradigms, like the table view that we just saw, the utility application that we just saw, and making it less necessary to write code to somehow make view controllers interact. So if we follow this next screen by clicking Next with View Storyboards, what we'll get is an application that looks a bit like this. And let me go ahead and open up a different project called Storyboard from tonight's code, and this will give us a view of exactly what's different. In the Storyboard folder, the story begins as usual with main.m, and then up here we seem to have main view controller and flip side view controller. So what I've done was start with which template as a starting point apparently? So the utility application, and a couple of you did this, I think, accidentally, maybe last week when following along, since it was pointed out that your nib file looked a little different, or your UI looked a little different. And indeed, if we go to main storyboard.storyboard, we see a user interface that looks like this for a utility application, and it appears that we're seeing like two nibs simultaneously, the main view controller and the flip side view controller's UI in the same screen. But they're somehow connected via this transition, generally known as a segue. And indeed, that's what it is, because when you use a storyboard, you essentially get one master file for your user interface, and you wire this up all within itself. And you specify in code exactly what you want to happen when A segues to B. So the one line of code we need to draw attention to really is just this. If I go into my main view controller, notice that this is actually pretty straightforward. I've simply implemented a separate method this time called prepare for segue sender, And this is the method that's apparently going to be called whenever the user induces a transition from the first controller to the second controller. And you can see what it's doing here. If segue identifier is equal to the string, quote unquote, show alternate. So this string, show alternate, is completely arbitrary. It could have been foo, bar, baz, whatever. But it's a string that we'll see elsewhere. And apparently what's happening, if that is the identifier of the segue that the user wants to happen by having interacted with the application, we are going to call destination view controller on the segue set delegate to self. In other words, before the user transitions from this side to this side, we apparently want to inform the segue that the destination is going to be what, ultimately? Or rather, we want to inform the destination view controller that its delegate is going to be self, the main side. So recall the same paradigm in the utility application we played with in class that you've probably begun with for Evil Hangman or about to, whereby when you click that done button, you want the transition to go back and you need to know to whom to return control, in this case the main view controller. So that begs the question, where is this quoted string coming from? Where is this identifier for the segue? So if we go to the storyboard and I click on the segue itself, not much happens over here, but notice that this is apparently of type modal segue from button flip side view controller. That's the English friendly string. I'm going to have to make my UI a bit of a mess and open up over here the right-hand panel. And with that segue selected, if I go up here to the attributes inspector, notice that the programmer who made this template, in this case at Apple, manually typed in an identifier of show alternate. But again, that could have been foo, bar, any string there. And that's to uniquely identify that transition. So in short, if we want to somehow wire together the user interface in this different paradigm, whereby both sides of the application are in one file, we simply have to define what happens when that transition occurs. So I mention these now because if you want to take things further, say for your own native application, if you go that route for the third, you'll find that this is a very common paradigm now with iOS programming because it really eliminates a lot more of the wiring that you need to do and it centralizes the UI in one place. And as this picture kind of suggests, if you have a particularly complex UI, like a menu and then a submenu and other submenus and other submenus, you can wire them all together within the confines of the same tool. And it's just a simplification. Yeah? Good question. Is there a disadvantage? Not really. The gripe people tend to have with Interface Builder or using nibs or storyboards in this way is that you don't have as much low-level control and you can't necessarily, sometimes takes more steps to implement than you want. And once you start having to write code to talk to your nib files and whatnot, at that point a lot of people feel, I'll just do it all from scratch. And so that's why we just saw in the master view, the master detail application, the master was all code, even though the detail used a bit of wiring, and the no nib example last week was just all code. So it's just a trade-off, and a lot of people, seasoned iOS developers, tend to prefer just doing things from scratch. And of course, if you're bored with iOS's built-in UI and aesthetics, you have to do it from scratch if you want to layer things on top. Good question. All right, so let's start something truly from scratch now. And based on time, we can pull a pre-baked cake out of the oven, namely implementing an automated teller machine, so a cash machine, a bank machine, that simulates the idea of depositing money into a bank account and actually doing some math to keep track of a total account balance. So let me go ahead and create a new project. We'll do this as a single view application just to keep the focus now on the logic and less on details like the transitions between scenes. And let's go ahead and start. I'll call this ATM. I'm not going to use storyboards. I'm going to use the lower level nib approach, especially since we only need one anyway. I'm going to go ahead and click Next, save it on my desktop. And now I get our standard files over here on the top left. We could tell the story as before, but it's probably getting a little redundant now. Main.m somehow invokes the app delegate, somehow invokes the view controller, and the UI for the view controller comes from the nib. So let's go ahead and create a little bit of an interface here for my ATM. So I'm going to go ahead and make my whole background white just because. And then let's see. I want my ATM to look more like maybe a calculator with a total input field up here, maybe a total account balance down here, and then a whole bunch of numbers. So let's start to wire this up. I'm going to go ahead and have a UI label up top here. I'm going to drag it to be as wide as is recommended. Let me go ahead and increase that font size to make it, let's say 36. Okay, now we'll go ahead and make it a little bigger. And now let me go ahead and do another label that's down here toward the bottom. This is going to be my, actually, let's just copy and paste this so we get the same font size more quickly. I'm going to go down here. This will be my balance. All right, and now I need a whole bunch of buttons to represent this thing. So I'm going to go into my rounded rect button here. And let's see, this will be the number, let's see. Let's go ahead and match this lest we get it backwards. Let's go in to save time to the ATM, Xcode project, and ... so that we don't spend all day dragging and dropping. Voila. Now I have this interface. So what's now on the screen? Well, I right-aligned the text. So just by clicking in the Attributes Inspector, I centered this field here, and I added another UI label just to say balance, just for user interface. So there's one label, two labels, three labels. So these aren't input text fields per se, but they're sort of output displays. So in my code, I can display what the user's typing here, and I can display what the user has in their account down here. All right, so what might I want to do next? Well, the goal is I want the user to be able to type in like 50 deposit in order to deposit $50 in his or her account, and then I want to see 50 down here. And if I then do 10 deposit, I want to see a total account balance of 60 down here. So we somehow need to represent a few things that are going on here. One, all of these buttons need to be somehow connected to my code so that when I push the number 5 and then the number 0, a couple of things happen. One, those numbers get saved in RAM somewhere. Two, they display like a calculator would, 5, 0 up here. So I somehow need my code to talk to my interface, which is going to require a IB. In this case, if I want my code to talk to the UI, an IB outlet in that direction. By contrast, when I push a button, I want to trigger an IB action to my code. So I have some blue lines going in both directions, or we can do it purely in code as we've seen. And then I have two special buttons, deposit, of course, and then the clear button. So before we get there, I'm going to go ahead and propose, let me roll back in time. So here's where we were a moment ago, and let's assume that we're seeing now the cake being made, and then finally we'll skip to the ending here. So as we're making this thing, I've realized in the top left that this is an opportunity to have a model, the M in MVC, because this is like a mechanical machine or a digital machine that somehow has to store account balances. So what might I want to model in this program? Well, maybe the notion of an account. In fact, an account, like a bank account, could be modeled pretty well as an object or an instantiation of some class. And inside of an account is going to be one or more pieces of data. And the only one I'm going to care about for now is the account balance. So in order to do this, I'm going to go up to an option that we probably haven't used, but it's pretty straightforward, File, New File. So not a new project, just create a new file. And you'll see an interface that looks a little overwhelming at first because there's a lot of options, but really they're just different templates via which to start a new file. And all I'm going to want is an Objective-C class. So I'm going to go ahead and click Next. And I'm going to call this thing account. It's asking me what should it be a subclass of. NSObject is fine. Most everything descends from NSObject, so that's fine for my purposes. I'm going to go ahead and click Next. Going to go ahead and click Create. And voila, at the top left of my file, I now have the ability to represent an account object. So let's see what I've gotten for free. In account.h, I have interface, account descends from NSObject. And in account.m, I just have a blank implementation. So now I have an opportunity, again, for the first time to implement some notion of an account balance. And I'm going to propose the following. In my .h file, I'm going to propose a property that's going to have, let's say, a sign. We'll come back to that in a moment. Non-atomic attributes. I'm going to propose that this be an unsigned long balance. So a couple of details pop out here. So one, unsigned, just to be clear, means that the value can only be non-negative. So it can include 0. So that's what unsigned would mean. All right, so long, what's that? What's the role there? We want it to be 64-bit. So on this platform, doing a long gives me a 64-bit number, and that just means it's pretty darn big. I want to avoid what's generally called integer overflow, whereby if we type in too big of a number, I don't want it to roll over with as high probability to some random number. Turns out this is not an adequate defense. We can still break this ATM and deposit an arbitrary amount of money in our account pretty easily, but we'll simulate that in a bit. Non-atomic, this just has to do with multi-threading. I'm writing very simple code here. There's not going to be two threads trying to touch the account at once, though there could be certainly in a world with multiple ATMs on a network, but we'll keep it simple. And assign now is different. Typically, we've seen what attribute in lines like this? Yeah. So okay, we've seen copy, but more commonly thus far in our examples, we've seen strong or weak in this case. So assign literally just does just that. It gives me a setter that literally moves a value from the right-hand side of an expression to the left-hand side. There's no checking for duplicate values. There's no deep copying of objects. And this is perfectly fine for what's generally called a primitive, like a long-long. A long-long is just 64 bits. To copy 64 bits, you just assign it from the right to the left with an equal sign in between. So there's no need for strong or weak, which have to do with objects and pointers. A copy also has to do with objects and pointers. Assign is just for primitive. So that's all I've specified here. Okay, and by default, is this read-write or read-only? It's read-write, which means I get a setter and a getter automatically by having declared this property here. Okay, so we're going to keep the account simple. We're not going to bother with account numbers or names or any of that. We're just going to keep it simple with our placeholder there. And now in my implementation of this object, I might want to do one thing. So it turns out an NS object, recall, comes with some default functionality in the form of an init method. And that init method is defined in the NSObject class. And typically that method does nothing by default, but it's an opportunity for us to do something. What might you want to do in the way of initialization when you instantiate an account object for the first time? Yeah, so why don't we set an initial balance? So the signature for an init method, if you look at the documentations for NSObject, or just in general, the convention in iOS is, or in Objective-C, is to have an instance method, hence the hyphen, returns an ID, which is a pointer or nil, and it's called init by convention. So it's kind of like it's the initialization half of a constructor. Alloc would be the other half. Again, a common paradigm is to say now this: if self gets super init, so this is just a common way of saying, one, call the parent class's implementation of init, make sure that it doesn't return nil, because if it does return nil, I don't want to start doing work unnecessarily, lest I create problems. And now, if all is well, I'm going to do self.balance gets 0, and then I need to return myself. So that's it. If I deleted all of this, we wouldn't be initializing the primitive to a known value. So this way, we have a default value, or we could be nice, right? If the first time you sign up for a bank account, you get some free gift, maybe you get $100 in your account, and we could do that right here. Yes?
Why do you have to do super alloc and init?
Super alloc and in. Because that would be bad. Because when init is called, alloc has already been called. So the convention is call alloc, then init. So if init called alloc, that would be trying to instantiate the object twice. Good question. All right, so that's it. This is a super, super simple model, if you will, but it's representative of how we could go about encapsulating information, and maybe in a fancier world, this information would come from a database, and if it did, it could go in this model code. But we're going to use it just as an abstraction for what an actual account balance is. So now, what more do we have to do? Well, let me jump back to the pre-baked version that looks now like this. Notice that at top left, I have the exact same code that I wrote in advance. So I have a property called balance, and I have an implementation of init. So if we go back to the nib, I also did a few things in advance, consistent with what we said was necessary. One, I wired all of the buttons to my code using IB actions, and I wired my code to two different UI labels via IB outlets. So two directions. Now how can I check what directions they went in? Well, let me go ahead and choose the number 7, and notice that if I hold Control and click on there, there's a whole bunch in this drop-down, but the interesting one, recall from last week, is touch up inside. That's this act. And the result of that is to do what? Files owner digit. What could that mean? Call a method called digit on what object? On the files owner, which in this case is going to be view controller. Exactly. So I'm in the view controller class is nib, and the files owner is going to be the .m file. So let's take a look at the .m file And indeed, there is, nested among a few other methods, a method called digit. So I've declared this as an instance method. It returns an IB action by convention, which is just synonymous with, remember your lower level C details? It's just void, just returns void, which means it returns nothing. And it takes a pointer called sender. And what is that going to be a pointer to? The button that was pressed. So this is my way of programmatically knowing what button was actually pressed. So here's a bit of a trick that we've leveraged with the UI view class. Notice in this first line of code, I'm doing the following. On the left-hand side, I instantiate what? Good, pointer to a UI button. And I keep asking this question so that the answer is not allocate a UI button, which is not the case. I've allocated a pointer to a UI button. On the right-hand side, what have I done? Casting. Exactly. So this is a C-style cast whereby sender's type, I don't really know. Because I declared it as an argument of a type ID, I don't actually really know what its type is. So therefore, I don't necessarily know what methods I can call on it, and therefore Xcode doesn't know whether or not to yell at me if I try calling a method maybe that doesn't exist. It's okay to send messages to objects even if they don't respond to them, but if I want to really leverage my compiler and my IDE here, it's nice if it can yell at me when I'm doing stupid things. So I can explicitly say that sender is of type UI button so that now anything I do with B will be known by Xcode as referring to a button. Yeah? Good question. That would be perfectly fine. You could do this. Let me scroll over. Your code just starts to look a little less readable, but that's perfectly fine. And there's another way we could do this. We don't strictly have to say ID up here. We could do this and then eliminate this line altogether and just refer to sender. And the only reason I left it this way is really just by convention. Typically, Apple always says ID as the type of the argument and then casts it explicitly. But functionally, it's the same. The compiler won't yell at you. OK, so here now is a little grade school arithmetic that's finally coming back to be useful. Why does this line work? Well, self.amount is referring to what? I actually don't know what amount is. So what is self in this context? What class are we inside of? So this is the view controller. See, I got out of sync here with my order of operations. Let me go to the .h file, and it looks like there's a few things in here. So let's actually pause for a moment and look at what's inside of this particular view controller. So I have a property that's called account, and it points to an account object. OK, so there's my bank account. There is my controller linking to my M in MVC model. So we saw that arrow promised in the picture earlier. What's next? A long amount. I'm not sure why there's an amount there, so we'll come back to that. There seems to be some duplication here for some reason, but we'll come back to that. And then here's the IB outlet and the IB action that I mentioned earlier. I apparently called it balance label for the balance at the bottom and deposit label for the current number I'm typing in at the top, just like a calculator. And then I have some instance methods that are declared down here. As a spoiler, we're looking at digit, and this is the method that's going to get invoked anytime I touch a digit, a number. Deposit is when I hit the green deposit button. Clear is when I hit the red clear button. And show is just a helper method I wrote to keep my code organized and centralize all of the view code, as we'll see in a moment. So account, to be clear, is an account, a pointer to an account object. So now we go back to the .m file. And now in digit, what am I doing? I'm storing self.amount, which was another unsigned long, and I'm assigning it the return value of self.amount times 10 plus b.tag. What do you think this is doing?
So amount just holds what's the current displayed right now.
Good.
So every time you click a button, you want to multiply it by 10 because every time you click the button, then you're shifting the digits over.
Exactly.
Add the 1 digit.
Exactly. So when I referred to grade school earlier, I just meant to the process of every time you multiply by 10, it shifts the number over to the left, and that's effectively the behavior you want. Every time you type in an additional number, you want to shift the current numbers over and put the new one there, and you can do that arithmetically by just doing multiply by 10 of the current value and then add in b.tag. So this is curious. So b is a UI button. A UI button is a descendant from a class called UI view. And it turns out, if we read the documentation, that a UI view has a property called, take a guess, tag, which is just a number field. It's an NS integer that you can use for whatever you want. So for simplicity, what I decided to do here in my view controller is this. Notice I've got the number 7 here selected arbitrarily, but we can see it on the other numbers as well. If I go up to the attributes inspector, notice that the contents of this button are the number 7. But they could have been 7, even though that would look a little strange. But this is only to say that this is a string up here, even though it looks like a number. So that's the label of the button. But if I scroll down and scroll down, notice that under View, which is just Apple's way of categorizing attributes that are specific to UI view objects, what field does a UI view apparently also have? It's a tag. So TAG, all lowercase. This is just a property in the UI view class. That's a number that you can use for whatever you want. Typically, the cleanest way to use this is with constants that are defined elsewhere so that there's some kind of programmatic mapping to the values. But for simplicity, because this is a very simple application, I decided to just go through each of my buttons. And because by wonderful coincidence, my buttons are meant to represent numbers, I decided to assign each a tag that's identical to its label. So I manually went in and made 7 equal to 7. 8 is equal to 8. And notice that the number is going to be changing there at top right. If I click on 2, it's 2. 0, it's 0. And then notice deposit and clear are also 0. But that's not a problem because I probably wired those guys up to different methods. So I don't have to worry about confusing one 0 for the other. So if we go back to the button 7 and control click on it, notice that it will send the digit message to file's owner whenever it's pressed up inside. That means that digit gets called anytime I push a number, and we saw in the .m file that that induces a little bit of arithmetic where I multiply the current amount in that top field by 10, I then add b.tag to it, and then I call my helper method show. And show, this is not something that comes with iOS. I wrote it myself. It was just my way of centralizing all the code related to updating the UI, and it looks like this. I have 2 lines of code, even though they wrap, and I am setting my self's balance label property, the text thereof, to the result of calling NSStrings string with format convenience method, passing in this very cryptic looking string, $%LLU. What in the world does that mean? Well, what's the $sign mean? It's a $sign, money. Okay, so %LLU is a placeholder that represents exactly a long unsigned value. So if you're familiar with C, %D is what you typically use for a decimal number, but in this case we want a long and unsigned. So cryptic, but it's perfect for what we want for our unsigned long. What do I want to paste into that value? Comma self.account.balance, whose type is again unsigned long. So I called this a convenience method. In what sense is string with format a convenience method? What type of method is string with format apparently, based on this snippet? A class method. Class method because we don't call alloc, you just call it directly. So it's a convenience method, in the sense that you don't have to call alloc, you don't then have to call init and jump through these hoops, you just call this method. And again, and I think we said this a couple of weeks ago, this is a very common paradigm in iOS. If you have a class called NSString or string, having convenience methods that start with roughly the class name and then with is a common way of instantiating objects without calling alloc. So common paradigm is all. Lastly, the thing down here is identical. We're just doing the same thing with the current amount. So notice the dichotomy. I've got 2 variables called amount. One is in my view controller, and where's the other? In the account object. And notice the distinction. What's in my account is what I've already deposited. But what's in the other variable called amount, which is in the view controller, is just storing what value? What the user has typed in thus far. So if we run this thing now, even though we haven't seen quite all of the pieces, and we pull up the actual user interface, and I click the number 7, that digit message has been sent. We have done the math of multiplying 0 by 10, which is the default value, plus 7, and then I've called the show method, which updates the value to be 7. But only once I click deposit here is the deposit method called. So let's check that. If I go to the nib, and I go to control click on deposit, scroll down here, touch up inside is mapped to deposit. So now, if I want to see what deposit does, if I go into my .m and scroll down to here, that is doing what? Self.account.balance plus equals self amount. So it's adding what's actually in the controller's variable to the ATM's variable. What am I doing with self.amount equals 0? Well, I'm just clearing my local value, and then I'm updating the UI by calling show again. So this is actually a really clean example of MVC by keeping these barriers between everything. The controller's doing all of my logic and my temporary arithmetic, but only once I'm ready to make the deposit do I talk to the model, and only once I've done that do I show things by having the controller call on the view by way of this method I called show. All right, so which method is probably going to be pretty similar? Clear. If we look at clear, super simple. It's the result of having wired things together. But suppose I've screwed up and I forgot to wire up the clear method, which I can simulate by clicking the X there. And so now the clear button has no effect. From what to what do I need to click and drag in order to reconstruct that IB out action or IB outlet? First, what is it? IB action, what do I have to do? Click on the clear. All right, holding control, go to where? Files owner, let go. There I see a list of all of the methods that I can call. The one that doesn't have a hyphen means I just haven't wired it up yet. I'm going to go do that, and now we've fixed it. Conversely, if I screwed up my label, which currently, if I click on this with control, is mapped to deposit label. How do I fix this? Well, I can control click on my label, go to files owner, and it's just the other way. So IB outlets go from files owner to deposit. There it is, deposit label, wire it up, and now I've resurrected the actual interface. Any questions? All right, so let me propose with this particular one, especially when it comes time to your native applications, if you want to start with something from scratch, think about using that as the beginnings of an application because it draws these fairly clear lines between M, V, and C, which recall is just the picture that we looked at earlier and as well last week. All right, so let's forge ahead to something that's going to give us a new capability altogether. Rather than focus on reinforcing some of the things we've done, let's go ahead and consider this. It turns out that there's a whole bunch of ways that we can start storing information. To date, we have not stored any information persistently in a program that we've written. Every time you quit the application, any things that you've been storing in variables, anything you've stored in properties just disappears altogether. But it turns out in iOS we can store things in a number of formats. So we have things called property lists, which we've actually encountered before, something called NS defaults or settings, SQLite, XML or JSON, even something called core data. So property lists, we've seen those before. What's a property list or plist file? .plist. Yeah. Exactly. It's a dictionary of strings. It's a file containing key-value pairs, and we've seen this in Xcode in the form of a nice little pretty table form with keys on the left and values on the right, but that's just the user-friendly way of showing you what's really an XML file with data types like strings and integers underneath the hood. But it's useful, and if you've dived into Evil Hangman already, you know that this is the format in which we've provided you with a whole bunch of words. It happens to be an XML file underneath the hood, and you can see as much if you actually download that. In fact, let's go over to the distribution code, and if I go to cs76.net/projects, and we have the full words.plist file there. If I try to open it in Xcode, it's going to open in this big chart here, which is kind of misleading because there aren't really keys called item 0, item 1. This is just their way of representing an array in this table format. But if I instead go into my downloads folder here, and I open up words.plist with, let's say, Text Wrangler, which is just a simple text editor, we are going to see this, which is XML. If unfamiliar, XML is like HTML, but you get to make up your own tag names. And so here we have an element called array, and then a whole bunch of strings. So that is what we have given you for this dictionary, and there's thousands and thousands of lines here. So this is actually a perfect candidate if implementing a program that listed all these words, not to keep all of them around in like UI table cells if you were using a table view controller like we did earlier. So with regard to storage, property lists are nice when at least you have static information that you want to ship with your application. But they can also be used effectively to store defaults. You can store key-value pairs even when an application quits. And one of the things you'll get to use in Evil Hangman or dabble with in lab is NSDefaults, which is an interface for storing information persistently in applications so that when it quits, you can actually reload those same values after the fact. So what kind of uses might persistent storage like that have for an application? Why is this useful?
If you got a call while playing your game, then you could store data such that when they hung up the call, you could resume it.
Okay, good. So if you got a phone call, it interrupted your game, you could then reload the information that the state that the game was in so that you can continue playing it. So to be honest, you probably don't need to use property lists for that because so long as the application is backgrounded, you can keep stuff in RAM still, unless the user quits, in which case they're at a loss.
I was talking about NSDefaults.
Oh, I'm sorry. So even NSDefaults. So NSDefaults are truly meant to be default values, not state remembrance for the state of a game. So defaults would be like, do you want the sound on or off by default? What's your nickname by default? So NSDefaults are good for things like that, configurable options that the user might change in the game. Settings is just another UI. A lot of applications, like in Evil Hangman, will have settings built into the application, for instance, on the flip side, and indeed that's where you can store things like the preferred word length and number of guesses in an NSDefaults through that API, which ends up writing a file into the iPhone or to the iPad or the like. But you can also write code that allows you to hook into the settings icon on the iPhone or the iPad where you can move your settings there. It's really just a design decision. What people tend to do for simple settings, if you only have a few, they put them in the application itself. If there's lots and lots of settings, some people factor them out and put them under the settings icon on the phone. It's a little more annoying, though, because you have to exit the application and go to it to actually get at them. But you'll find that this is as easy as writing key value pairs to an object. So more on that with Evil Hangman. What's SQLite, if familiar?
Flat file SQL. It stores a SQL accessible database in a flat file.
Exactly. So a SQL, a structured query language, is a database language with which you can write information to a database and read it and use syntax that allows you to search the database fairly easily. You don't have to resort to linear search all of the time. And it's nice because you don't need a server. You don't need MySQL or Postgres or Oracle or anything like that. You just store it in a binary file in the same folder typically as your code. And what SQLite is, it's an API that lets you read and write from that file using select and insert and delete if you're familiar with that feature of SQL. The catch is, in iOS, the SQLite library is implemented not in Objective-C, but in C, which means the code looks horrific. It's very useful, it's very powerful, but it's also a bit arcane, and so people typically use other constructs, a couple of which we've discussed. XML, meanwhile, or JSON, is typically used when transporting information these days across the wire. So property lists are XML, but if you were to have your own arbitrary format, typically that's for a game or a program that somehow grabs information from a server on the internet. These are very useful data formats for exchanging information. And then finally, there's core data, which is an Apple SDK that allows you to abstract away the notion of a database altogether and define your database schema, define the keys and the values, the relations among them, using their graphical editor to wire things up a little more high level. And you had a question here. Is it possible to query a regular expression in SQLite, simplified one? SQL supports like queries, where you can use a subset of Perl's regular expressions, or which are common in other languages as well. So sort of. Good question. All right, so let's go back over here, and let's go into tonight's sources, and let's go into plist. So I, in advance, downloaded the plist file earlier on my own computer over here. Not that one. So now if I go into plist and go into the distribution code here, we'll see some of the usual friends. And let me go into main.m. Okay, no surprises there. Let me next go into appdelegate.h. No surprises there. Appdelegate.m. No surprises there. It seems to be handing off control now to viewcontroller.h. Really nothing going on there. Viewcontroller.m, finally. There's something going on in here. But let's wait. Let's go to the nib file. And for some reason, my example involves cities in California. So this has always been a stupid feature of Interface Builder. When you drag and drop a UI table view controller into an application, rather than show you your data or just blanks, they arbitrarily show you cities in California. Those are not in the application itself. It's like a screenshot of someone else's application, but mildly confusing. But if I now go back to my code, let's see what I'm doing. So recall that we looked at the master detail application earlier, which was a little complex, and I've stolen some of the simpler ideas from it just to implement the following application. If I go ahead and click Run up here, oops, let me quit the old simulator, and let me run this in the latest version of the simulator. It's going to pop open, and you might see some familiar words. So these are from a property list called small.plist, which I downloaded from the course's website. Recall that the project specification gives you a super short list just so you can tinker without worrying about hundreds of thousands of words. So that's just an XML file that I've literally dragged and dropped into the project, and somehow in code I'm opening this up. Yes? Oh, yes, you should. It's because I made these on another computer, and that one, there we go. Yeah, so with things like this, I'll fix these and re-upload them so you don't see these little warnings. It's because the computer I was creating them on was a slightly different version. Short answer, your code should have no warnings. Therefore, do as I say, not as I do. But I will fix that. Okay, so this plist file, I literally just dragged and dropped into the supporting files folder, but it's not really a folder. I could have put it anywhere into the project. And so that means all of the logic must be in this .m file. So let's see what's going on. This is my view controller class. I have chosen to implement this familiar method now, init with nibname bundle. And what am I doing in there? One, I'm calling the parent class's version of that method. So that's familiar construct, checking its return value to make sure it's not nil. And then I'm apparently loading words. So how do you go about loading an XML file, specifically a property list, from your application if you've dragged and dropped it in there or added it by going to File, Add File? Well, I apparently call nsBundle main bundle. So this is a way of saying to iOS, give me essentially the path to the default folder, the default root folder of this application. Then give me specifically the path for the following resource, quote unquote small, and what data type is it? Plist. So this is a way of telling iOS, give me a file called give me a file called small.something. That something is plist because it's of type plist, and this helps it know how to load the file, whether it's a property list, a binary file, or some generic text file. Then I'm out doing this. On the left-hand side, what's going on here in this highlighted portion? Good, I'm creating a pointer to an NSArray object, and on the right-hand side, I'm calling NSArray alloc init with contents of file. So there's a bunch of different ways to do this. I have chosen to use NSArray's alloc method, and then the init method called inits with contents of file, and it turns out that if I read the documentation for that method, it just knows how to load that information into the file. But I thought NSArrays were immutable. In other words, I thought you couldn't change them, but I'm clearly initializing this one with words. How do we reconcile that? What's that? I never allocated it or initialized it, but I did allocate and initialize it here, right?
You haven't changed the array, and you just have a type NSArray pointer.
So that's okay on the left-hand side. But why is this not a mutable array? I'm adding stuff to it, which means I'm changing it, right? Yes, that's the key distinction. If you could never mutate arrays, you could never have anything in an NS array. It would be a useless object. But in this case, we have an NS array that's being initialized at the point of allocation with the contents of a file. So the fact that it's an NS array just means I can't change it after this line of code. And that makes sense because if this application is just going to show this list of words, much like Evil Hangman is going to have a long list of words in its memory, you're not going to want to change it. You just want to have one copy of that lying around. And it's slightly more efficient to have the NSArray class instead of the NSMutable array because, one, there's less functionality. There's not the editing code related to it. And two, you protect yourself against yourself. You can't accidentally delete a word from your dictionary if you've said to the compiler, this is an immutable NSArray. All right, so lastly, I'm just remembering that pointer by assigning it to my property called words, and then I'm returning myself. So at this point in the program, I have loaded that property list into memory, stored it in a property, so now I have access to an NSArray that I can iterate over and do whatever I want. So the application now looks like this. It's a table of words, and I now somehow have to render 1, 2, 3, 4, 5 cells. But I don't proactively push the cells to the UI. I'm instead going to have the iOS is going to ask me, what do you want at this cell? What do you want at this cell? What do you want at this cell? Or rather, what do you want at this row, this row, this row? And I have to return a cell to it. So if I go back to the code, notice that we have this thing, number of sections in table view. So that's OK here because it's just one big table. There's not different groupings. As an aside, if I go back here, let me see if I can show you the opposite. If I go into settings, this is a UI table view. So if you've owned an iOS device, you've seen UI table views for years now. This is a UI table view with 1, 2, 3, at least 4 sections, each of which has some non-zero number of rows. So that's all we mean by sections. But the game we're playing, or the program we're using here, just has one such section since we don't see the gray. So what next? Actually, let me delete for simplicity, since it's not necessary here. And now we have table view, cell for row at index path. When is this method called? When or why is this method called? What's that? When you try to get a cell and you pass in the index path, yes. So this is really the operating system is going to call this method, or more specifically, the controller is going to call this method, or rather, the view is going to call this method when I want to render a cell on the screen, and it's going to say what belongs at section 0, row 0. What belongs at section 0, row 1, row 2, row 3. And my job, as we saw earlier with master detail, is to return to this thing an object representing that row in the table with whatever text I want, whatever buttons I want inside. So we have this same trick using the reusable cells. I'm using quote-unquote cell again this time. If not, I instantiate it as needed. And then down here, I am initializing the cell as follows. 1, I'm setting its so-called selection style to be UI table view cell selection style none. What does that mean? It just means that when the user's finger clicks on this table view, like I'm doing with my mouse, nothing happens. It doesn't become blue. It doesn't get selected. Correct. It's asking me, what do you want here? What do you want here? What do you want here? And I have to hand it back the rectangular cell, effectively. Exactly. And then I'm setting the cell's text label text equal to be whatever is returned from the object at index row. So what's at index 0, what's at index 1. And then I'm passing that message to words so that I get the 0th object, the 1 object, 2 object, 3, and so forth. And if I change this, for instance, to that, semicolon, and rerun the application, what I should get, despite all of that effort to store data, is just the same string again and again and again. So that's truly a method that's being called. Finally, down here, this one's different. Table view number of rows in section. This is the method that that's going to be invoked when asked how many rows does section 0 have, so that iOS knows how many times to ask you for the cells. In this case, I have not hard-coded a value because I don't remember how many words are in the property list, and maybe it would even change with an update. So we pass in the count message to self.words, which gives me the array's length. Yes?
So in the case where you're passing through a file, where you have an array that's not mutable,
Okay.
you're editing the actual file itself. Like the plist itself. And you're keeping
No editing has happened to the plist here.
No, but I'm saying in terms of like if you wanted to, if the plist had like more content in it,
Okay.
this would already account.
Yes.
Okay.
Exactly. This is good design because even though I could go to the application and I can go 1, 2, 3, 4, there's 5 words in my plist, I could just write return 5. The catch is that whereas it's reasonable to assume that my UI has one section forever because that's how I designed the user experience to be with just one big table view, no notion of sections, that in theory could change. And it's a poor design decision if not only do I have to update the property list in a year when I ship a new version with 10 words and not 5, but to also have to change it there. It's just inviting bugs and unmaintainability. So that's all. All right, so nice and sexier maybe, but let's actually do something where we interact with the glass of the screen and do something like clicking or dragging or pinching and see how we can add that element, particularly as you contemplate what you might want to do for your third and final project. So it turns out that iOS supports a whole bunch of gestures, and you're probably familiar with these naturally if you have a device like this, but they all reduce to some key class names. So we have things like UI tap gesture recognizer. This is the type of object that if you instantiate, you have the ability to detect that on an arbitrary portion of the screen, not necessarily right on top of a button, which is handled for you automatically. Pinch, which is doing something like this, often to zoom. Rotations, kind of twisting your fingers around. Swiping left to right, up to down. Pan gesture, if you want to move something across the screen. And long press, if you want to click and hold for like a second or two. That too can be detected differently. And if you've used Google Maps or Apple Maps or the like, you've experienced a bunch of these different UI mechanisms. So how do we start doing that? Well, let me go into some code and our last project here for the evening and open up the one called gestures. Now, in advance, I went on Facebook and downloaded a few photographs. Let me go ahead and run this application. And we have this application here. And if we swipe to the right, there's his graduation. And one more in his plumber's outfit from this weekend. So we can keep flipping through this, and each time I swipe from right to left, even though you can just barely see my mouse, it's like I'm sliding my finger from left to right. And I kept it simple. I didn't do it quite so that he's sliding off the screen. As soon as I start sliding, it just jumps off to the side, just to keep it simple. But also, if I click and hold on like his nose, it's going to nag at me because I'm using a long press gesture recognizer. So how do we go about implementing this and implementing that kind of functionality? Well, let's go into this. So in my project here, I've got some familiar files and some new ones. Under supporting files, I have 3 photos of Rob. So these are just JPEGs that I dragged and dropped after renaming them, after downloading them from Facebook. I encourage you to friend Rob on Facebook. If you then drag them into the project, I can now access them programmatically. And so now I can do something like this. In main.m is some usual code. In appdelegate.h is some usual code. In appdelegate.m is some usual code. So nothing new here. We're building on the same principles as before. So the magic must be somewhere in my nib and my view controller files. So my view controller.nib file also looks very simple. I dragged and dropped a class called UI image view, which is like a video player, but for images. It's just a placeholder for a single ping or GIF or JPEG or the like. And I configured it to just fill the whole screen. So I need to somehow programmatically have access to that. So a good place to start, again, when downloading code that someone else wrote or that you download online as part of a bigger project, is just control-click on it. And it looks like there is a image view property somewhere that's pointing to file's owner. So there's some kind of linkage happening here, some kind of outlet to the file's owner. So let's look at my .h file. And if I go into my .h file, nothing there. That's interesting. Viewcontroller.m. So I've tried to take things one step further here. Thus far, we've been putting properties and method declarations in our .h files, which is a common convention, but it's not strictly necessary because if all of my methods are implemented in this same file, and if no one else is going to be importing my .h file, and they probably shouldn't be importing my view controller. You would typically import utility classes or files with constants or files for models and the like. There's really no reason for me to advertise to the world, in principle, in my .h file, all of this internal functionality. So I can certainly just declare these properties as private by putting them in this file. And I say private typically because, again, you can still send messages to objects. They may very well respond. But just in the interest of not advertising features, much like Apple does not advertise certain APIs, they keep them private, though people figure it out, I've decided to declare all of my properties here in this file, my .m. So I seem to have a few properties. One is a Boolean called alert in progress. And I ended up using that, if I fast forward to the end of the story, because I needed to remember if and when I had touched Rob's face for too long and therefore triggered the alert view, because I ran into a bug through trial and error that if I kept holding, I might get multiple alert views, and I didn't want to do that. So I wanted a simple locking mechanism to make sure I only open one alert view ever. So next I have an image view pointer to a UI image view, and that's my IB outlet. So that's the wiring between that IB image view, that UI image view and my code. Then I have an index, not sure what that is, and then I have some ROBs in the form of a pointer to an NS array. So let's take a guess. What is going to go in that NS array probably? Yeah. The images. So specifically maybe the names of the images, though we'll see in just a moment. And then the int called index, where I am. So I realized, again, by thinking through the design of this, if I want to implement this sort of carousel of ROBs and I want it to wrap around so that the third image goes back to the first image, I decided just to use an index that's going to be 0, 1, 2, 0, 1, 2, and I can use some modular arithmetic to wrap around like you might have done in other languages. So that's where this is going. Meanwhile, I've got some private methods, private only in the sense that they're not advertised in my .h, called alert view did dismiss with button index. We've seen that before. When is that method called? Think back to last week. When the user clicks the cancellation button, however labeled, that big default button, I have another method called handle long press and then handle swipe. And those are implemented to receive something called a recognizer. So a pointer to some kind of object that has recognized what the user has done so I can glean some information about it. So now if I scroll down, what am I going to do when... Let's do the handle long press, because it's a little simpler. So when I click and hold on Rob's nose, or frankly anywhere on the image, it doesn't matter based on how I've implemented this, what is going to happen? Well, iOS is going to recognize that you're holding Rob's face down for quite some time, and therefore some code's going to get executed, specifically this method, handle long press. I'm going to be passed a pointer to the recognizer in case that's useful. And what I decided to do with that information here is what you saw. I'm going to first check, wait a minute, is there already alert in progress? This is the bool that I referred to earlier, just to make sure we don't get stuck in an infinite loop by holding his face for 4 seconds instead of just 2. Then I set it to yes, so that I remember. And this is single-threaded code at this point, so it's not a problem if I'm still holding down. Then I'm going to go ahead and allocate a UI alert view. And we saw this code last time, even though the words are now different. It's going to say, hey, stop that. I have a delegate of self, so not nil, and a cancel button of fine. So this delegate of self is used for what purpose? To tell the view controller that it is done, that the user has dismissed it specifically. So not the view controller. And that is what invokes this method, recall, which we said a moment ago, is the method that's called when you click that close button on a UI alert view. So all of that stuff is pretty much identical to what we saw last week. So that's the method that's called when I do a long press. But how did I teach the program to even listen for those long presses on the image in question? Well, if I scroll down, we look to a couple of places here. One is init with nib name. So this, again, is going to be that method that's automatically called when you are using nibs in your program. This is the opposite of using storyboards, for instance, but there's a similar mechanism for those. So init with nib name is copy and pasted essentially from before, but I've added a bit of code in the middle. I've first said alert in progress, no, because I want to know by default there is no long press, and that makes sense. When the program starts, no one's touching it by default. And then I prepare the ROBs, so to speak, and this is one way of initializing the array. I alloc an NS array, init with objects, and if I am not loading it from a file, for instance, just from a comma-separated list, the syntax is string, comma, string, comma, string, comma, nil, all in square brackets. So that, much like C, is how you can declare an array statically. The nil is important. You have to terminate this C-style array for that reason. And then self.index gets 0. What does this mean? What's the implication? Yeah, start with the first ROB at index location 0. So next, view did load, recall, is the method that's called once your view, your user interface has been loaded. And this is your point at which to start configuring some last-minute details after everything's been opened up from the nib file, for instance. So this is new code, but hopefully pretty readable. So notice I first call the parent class's version of this. Whoops. The parent class. So I call superViewDidLoad. Then I load the image. So self.imageView.image. Self.imageView is what? It's a property of type UI ImageView. If I read the documentation for UI ImageView, turns out that a UI ImageView has a property called image, whose value is a pointer to a UI image object, apparently. We've not seen this before, but you can now read it from the code itself. So this class here is called UI image. Turns out it has a convenience method called image_named, whereby if I get the ith rob at the current index, so give me robs bracket 0, but do it dynamically in code here, that is going to give me an image object, a UI image with rob, and I'm going to plop it into the carousel, essentially, the UI image view that allows me to show the image to someone. So now I'm going to listen for presses on Rob's image. So the code's a little ugly, but what I'm doing is declaring a pointer called longPressGesture of type UI longPressGesture recognizer. I am assigning it the return value of calling UI longPressGesture recognizer alloc. So just give me one of these recognizers. I'm initializing it with a target, self. We'll come back to that in a second. Action called handle longPress. So in layman's terms, this is listening for long press, but in slightly more technical terms, what are we telling the UI longPressGesture recognizer object exactly with in it with target and action here?
Well, first you're saying that the message to be sent when the long press happens is handle long press.
Good.
And you're also saying you should send that message to self, so the view controller.
Exactly. So this, again, to recap, means when you detect a UI long press, a couple seconds down with your finger, send the message handle long press, which could have been named anything. I came up with that method, but pass it to specifically myself, the same view controller. And that's why the method earlier in the file is indeed invoked when we hold down the one's finger and call handle long press. So the other recognizers, let's see first, before we see them in action one last time, listen for right swipe. So how do I do this? Same idea. I allocated UI swipe gesture recognizer. I initialize it with target self, and this time I tell it call handle swipe when the user swipes from a certain direction. But what direction is that? In this case, I have to do one additional step. I have to specify the direction, and according to the documentation, swipe gestures have a direction property, and this crazy long constant is what specifies when I go from right to left, essentially, this is what should actually happen. What should happen? Well, here is how we add to an image view, just like we did a few lines ago for the long press. This is how we add a recognizer to an existing view object that is on the screen. You create this recognizer, and you sort of glue it down onto the view so that that view triggers these various actions. Listen for left swipe. I've done that with a separate line of code at the end there, just by changing the constant to be this, and that's so that we can swipe right to left or left to right to increment or decrement the robs. And if we go back up here, let's look at the code. Let me fix this. Rob we swapped in this year. Handle swipe, it works how? So this is the method that's called when we swipe right to left, left to right. This is how we figure out the direction. We ask the recognizer that was passed in via the sender argument what direction were you sent in. I'm using a switch, which is like an if-else, but just done slightly differently syntactically. And I decided to do this. If the user has swiped up-down or down-up, do nothing. Now, technically, these lines of code do nothing useful. I just left it there for explicitness' sake, but it immediately breaks, which means there's no effect whatsoever. Meanwhile, the direction left down here has to do a bit of math, and it took a moment to kind of think about this, but I'm updating the index value to be, when I go from right to left, +1, and then I need to wrap around with some modular arithmetic based on the length of the array. Down here, meanwhile, if I wanted to wrap around to the other direction, I had to effectively subtract by 1, but I wanted to make sure that we didn't go negative, so I also have some addition in there just to make sure that 2 goes to 1, 1 goes to 0, 0 goes to 2 and doesn't accidentally go negative. So just some basic modular arithmetic there. And then lastly, what actually updates Rob and updates him instantly is to change the property called image of the image view IB outlet to the image named whatever Rob is at that particular index. So could have implemented this different ways, could have stored the actual images in an array as opposed to the file names, but we kept it simple in this way so we could actually see the strings explicitly in the code. But this is how we can now start listening for these things. And any of these kinds of interactions, pinching and zooming and rotating, is implemented similarly by implementing one or more of these recognizers and then responding accordingly.
Does it handle if we have competing recognizers, say, happen to a long tab? And actually, it's a tab and it's a long tab. Does it only trigger the long tab?
So in that case, if you're detecting tap versus long tap, if you're holding long enough, it will only be a long tap. That's what defines it as long, holding it slightly too long. If you do it within the window, and I think it's 1 or 2 seconds, that would be a tap. But you won't get both if you're holding down like that. You'll just get the long tap.
So there's no way that from any gesture to callback step fire?
You could potentially induce multiple ones. You can give priority to them effectively by listening to which one fires first. And you can think of this again as layers, as to which layer is going to receive the gesture first if you've added to multiple objects. But for the case you described, they'd be mutually exclusive. Other questions? So out of curiosity, how many people are leaning toward web applications for their third and final choice of projects? Or give a bad answer there? Okay. All right, a few. And iOS applications? And undecided? Okay, so not bad. So start thinking about that, even though I know you're in the midst of evil hangman, but you'll soon get feedback by this Wednesday from the teaching fellows on the mobile local project, so you can start thinking about what you could have done better there, how you might do things differently for a third and final project if you go with HTML5 and JavaScript. Also think about the native applications, and again, when the specification goes up, you'll see that step 1 is to float the idea by your TF, and he will confirm or deny the appropriateness, the viability given the limited time, and will help guide you towards something that's doable, so that in a few weeks' time, we'll all have some cake and some exhibitions of projects. Why don't we call it a night here, and I'll stick around for questions. See you at lab.